The Triangulum Galaxy is a vast system of stars, gas, and dark matter. But hidden beneath its shimmering surface is a cosmic ocean of invisible forces, quietly shaping everything we see. Among these forces, galactic magnetic fields are some of the most mysterious and powerful. They thread through the interstellar medium like unseen rivers, creating invisible highways for charged particles and subtly steering the motion of gas across vast distances. Though we cannot see them directly, their influence is immense. These magnetic fields accelerate particles to near the speed of light, generating the cosmic rays that constantly bombard every part of the galaxy, including Earth. These high-energy particles carry information about supernovae, stellar winds, and exotic cosmic phenomena. At the same time, these fields guide filamentary structures within the galaxy, long, thread-like strands of gas and dust that stretch across light years, linking distant star-forming regions. The interstellar medium, the space between the stars, is not empty. It's filled with a complex mixture of gas, dust, radiation, and plasma. And this environment is constantly changing, energized by multiple sources. Radiation from stars, cosmic rays, and even the residual light of the cosmic microwave background fill this medium. Together, they form a radiation field that influences chemistry, temperature, and structure. This radiation ionizes atoms, dissociates molecules, and drives the chemical reactions that give rise to complex organic compounds, the building blocks of life. In the densest regions of the interstellar medium, radiation is absorbed by tiny dust grains and re-emitted at longer wavelengths, creating a rich interplay between energy and matter. Though dust makes up only 1% of the interstellar medium by mass, its importance cannot be overstated. These microscopic particles, often smaller than the wavelength of visible light, are composed of silicates, carbon, ices, and metals. Dust grains serve as catalysts for chemistry. On their surfaces, hydrogen atoms meet and form molecular hydrogen, the most abundant molecule in the universe. Other complex molecules like water, ammonia, and even organic compounds can form in these environments. Dust also regulates temperature by absorbing and radiating heat, shielding molecular clouds from harsh starlight, and creating cold pockets where stars can form. And perhaps most poetically, dust grains scatter light, giving rise to the beautiful nebulae we see in deep space photographs, glowing with the colors of ionized gas and illuminated by nearby stars. But this environment is not passive. As massive stars ignite and explode, they inject energy into the interstellar medium, creating shockwaves that compress and heat the gas. Supernova remnants can sweep up vast regions of dust and gas, shaping bubbles and cavities that ripple outward for hundreds of light years. This feedback loop, stars forming, dying, and reshaping their surroundings, is one of the most important processes in galaxy evolution. In Triangulum, astronomers have observed shells, arcs, and filaments formed by these energetic events. Many of these structures are aligned with the galaxy's magnetic field, showing just how interconnected gravity, gas, and magnetism really are. Studying these environments is challenging. We can't see magnetic fields or radiation directly. But through radio astronomy, polarization mapping, and infrared observations, scientists can trace their influence. Missions like Planck, ALMA, and the James Webb Space Telescope are helping us uncover the secrets of these invisible forces, revealing how they guide the dance of creation across the cosmos. And all of this, magnetic fields, radiation, dust, cosmic rays, is happening at once, constantly, quietly, behind the scenes. The stars may get the spotlight, but the stage on which they shine is just as fascinating. It's easy to forget that space is more than emptiness. It's alive with motion. It hums with energy. It glows with ancient light and vibrates with the echoes of stellar explosions. And in that interplay of the seen and unseen, galaxies like Triangulum take shape. They grow, they evolve, they produce life-giving elements, and maybe even life itself. So the next time you look at an image of a galaxy, think not just of the stars and spiral arms, but of the invisible framework that binds it all together. The magnetic threads, the radiation fields, the grains of dust drifting between the stars. Because it's in those hidden spaces that the future of the universe is written.